All right, folks, let's use those three nice corollaries that we just laid out. And in problem 2, we've got 2 parts. The first one says, but they both say, what's the measure of each numbered angle? So we want to find angle 1 in this case, and then over here it's going to be angle 2. But let's start with this first one, part A. Let's just take the angle out and see what arc it intercepts. It's this arc over here. This is, that looks pretty. This is a semicircle. Hopefully you realize that. So we've got just that angle 1 intercepts a semicircle, which means, circle. So measure of angle 1 equals 90 degrees. Nice, right? That's just what corollary 2 said. So we know it's going to be a right angle. Now let's jump over here. Ooh, angle 2, they give us a 70. I wonder if they're trying to be like a little tricksies. Are we going to use that 70? How's that 70 going to come in? Well, angle 2, look, it intercepts this arc over here. Ooh, but look at this. This angle also intercepts that same arc. I wish we had a corollary that might tell, oh wait, we do have a corollary that tells us exactly what to do here. So we've got angle 2 and that 38-degree angle. They intercept the same arc. And what does that mean? That means that measure of angle 2 is going to equal 38. They're going to be congruent. That's cool. All right. Let's scroll on down, slide on up to this little got it problem. You want to get the got it. You got it? It's really, okay, forget it. All right. And so we want to get the measured of each number angle over here. And they've thrown in a diameter. So that's interesting. I wonder if that's going to come into play. Yeah, because before, we didn't even use that 70, huh? Oh, well. Let's see what this diameter is going to do for us, if anything. So, check this out. We've got a quadrilateral, right? And let's start. I'm going to start backwards, I think. I'm going to start with number 4. So, angle 4, notice that it intercepts this big old arc up there and that big old arc. So is these two smaller arcs combined. So measure of angle 4 is going to be 1/2, because of the inscribed angle theorem, 60 plus 80, or in other words, 60 plus 80 is 140, half of that is going to be 70. That's the measure of angle 4. Cool. Not very tough at all. And then what about all of this business over here, the rest of the circle? Well, you know what? I'm not even going to use, I was going to like say, oh, this is going to be like 220 degrees. I'm just going to use what corollary 3 says. Corollary 3 says opposite angles, quadrilateral, are supplementary. So I'm just going to use that fact. So measure of angle 2 is going to be just 180 minus measure of angle 4, which is 70 degrees, right? They're opposite angles, so I can say that. It's gonna be measure of angle 2 plus 70 equals 180. So that's it. Measure of angle 2 is equal to 110. Nice. Now let's go back to, over here to 1 and 3. Yeah, I know I'm jumping around, but forgive me, please. Angle 1. Look at angle 1. What is angle 1 intercepting? Oh, that's the diameter, right? So this is going to be a semicircle out here. So angle 1 intercepts a semicircle. It's going to be, yes, just like the corollary said, 90 degrees. And then you can think about this a couple different ways. Angle 3 also intercepts a semicircle out here. So it's not going to be 90. Or if you want to think about these being opposite angles of a quadrilateral inscribed in a circle, they're going to be supplementary. So measure of angle 3 must also be 90 degrees. That is so awesome. Let's think. All right, let's go over to the next page. And we're going to do something interesting here. So in this diagram, they first give us, I'm going to kind of just look at it one at a time. They first give us an inscribed angle. And what they're trying to say is, well, you know what? What if we move this angle point, but we don't move these other 2 points? We'll keep the intercepted arc the same, but we move where the angle is. We're just going to slide it down in this direction, right? Just keep moving. It's kind of like one of those flip books. From here to here. You notice that the arc didn't change, right? And then to here, A is getting closer to C, and then boom, A is on top of C. A is C, in fact. So this whole time, this arc over here does not change, okay? So if this is X, then this angle is going to be 1/2 X, right? In each case, X, the angle still 1/2 X. This is X, still 1/2 X. And now when A is on top of C, this is X, this is still 1/2 X. And what do you have right now? You basically have, this is like a tangent line. It just intersects the circle at one point. So that's a tangent line essentially. And that's what we're going to talk about in this next theorem. You have a tangent line and a chord. Well, the arc that's formed, that arc is still going to be twice the measure of the angle down here between the chord and the tangent line. So let's draw that, a similar situation. So let's draw first a tangent line. Gotta get it just right. Yeah, that's okay. And then let's draw a chord. That's a chord right there. I can't even remember if I've defined a chord, but hopefully you know what it is. It's just, you know, a line that goes through a circle. Endpoints are on the circle. A diameter is a chord that goes through the center. But anyways, okay. So I'll call that A, I'll call that B. And notice there's this arc that's formed here, right? And you know what, let me get another point. I'll call it C over here. So this arc is going to be 2 times the measure of this angle. Or if you think about it the other way, the angle, the measure of angle BAC, is equal to 1/2 measure of arc AB. Okay? So this angle in here is 1/2 of that arc out here. And the same thing can be said for the other side, this big major arc as well, and for this angle down here. Okay, so let's use that. Let's use this theorem down here in this problem. Hopefully this isn't too tough at all, because, well, we'll use this fact. Measure of arc PMQ, it's 212 degrees. PMQ, that's this business out here. So that is 212 degrees. And they tell us SR is a tangent, that this is its point of tangency. And they want us to find angle PQR. That's actually over here. Well, you know what? Let's use this information first, this 212. If this whole thing is 212, then we know what this angle is. That's, so measure of angle SQP, that's going to be 1/2 of that arc. Measure of arc PMQ. So that equals 1/2 of 212, which means that angle SQP is going to be 106, right? And now, you know, we can do a similar thing on this side, but you know what fact I'm going to use? I'm going to use the fact that this angle and this angle, they're adjacent, and their sum equals, the sum is 180 degrees, so they are linear pair. So measure of angle SQP plus measure of angle RQP, it equals 180 degrees. And again, that's because, hopefully you remember what a linear pair is. I'm sure you do. They're a linear pair. And we know what SQP is. Oh, we know. So that means if you just do a little quick subtraction measure of angle R, QP, PQR, whatever, is 74 degrees. Awesome. All right. That's it for the notes. But what I want you to do on the back of this last page, ooh, sorry, I didn't give you that thought. Did you miss that? Did you get that? I'll give you a second to write it down. Okay, good. On the back of this last page, not there. Oh, there it is. I want you to answer these on your own. I want you to get this. Got it? Got it? Good. Answer these questions in detail. The first one, I want to see some work. If, you know, whatever work you can show. And then the second one, I want this explained, like a complete sentence or two. Okay? All right, good luck with that, and I will see you soon.